a second.
All right. So we've been looking at some of our trig functions, sine and cosine, using our graphing calculators. We're going to go in and make a page in our notebooks today that have all of the parent graphs for all of our trig functions, not just sine and cosine. So on your calculator, when you're graphing trig functions, you want to make sure that you are in radian mode. So if you just hit mode, you want to come down and make sure that radians are selected, not degrees. And then you go to your y equals menu to type this in. When it says sine theta, we are actually going to use sine x. So you hit sine and hit the x key like this. And there is a theta key on your calculator, which is confusing, but that's for something else that we'll do later. So you still just go ahead and call it x because it has an xy axis. Okay, and then you want to do a zoom trig. So if you hit zoom, I'm actually going to go up. Maybe not, because I have a bunch of extra stuff on here that I didn't used to have. Z trig is number 7. And that will give us the graph that goes from negative 2 pi on this side to 2 pi on this side. And so if you'll notice, this graph only has the right hand side, so we're just going to use this part. So, yeah, you got an issue. So go back to y equals. You got to turn that off, the plot off at the top. It's okay. All right, so sometimes you got to make sure when you go in your y equals that these plots don't have boxes on them. If they do, it'll try to still do some statistics stuff. Okay, so let's look at this graph. So the way that this is set up, this is 2 pi over here. So it means halfway is pi. No, that's not right. Mine is bigger than your guys's. So let me fix that really quick. Negative 2 pi. So you will not have to do this on your calculators unless you have the brand new ones. Okay, so this is what it should look like on your graphs. Does that look more like what you guys have?
Yes.
On the older calculators? So this is 2 pi. So this would be pi halfway, and then these are halves. So if we start here, sine goes through the origin. Sine of 0 is 0 when we're working on our unit circles. And then when you get over to pi over 2, it goes up to 1. So this is not going to go very high on this graph. That's okay. When I get to pi, it's back down to 0. And then at 3 pi over 2, 3 halves pi is like pi and a half. It's down at negative 1. And then when you come back up, it's at 2 pi. And then it just repeats. So we can put another, this would be 1 period. We could put another one in there. So if I go up to 5 pi over 2, it would go back up to 1 and back down at 3 pi, and it would keep going like this. So we can go through and talk about on the parent function when they haven't done anything to the graph what it looks like. So for sine, the period, we started here at 0 and we did all this up, down, and it started over when we got to 2 pi. And you can see that really clearly on the calculator. Every 2 pi, it repeats. So our period is 2 pi. And sometimes they'll mark that with just a T. Your midline is just going to be the x-axis, so that's not a really super exciting thing. But we can just use the x-axis as our midline and look at the amplitude. So what's the amplitude of this?
1.
It's just 1, because from that midline it goes up 1, it goes down 1. That's how much it varies from that midline right here on the x-axis. So we can say that for the original sine function, the amplitude is 1.
How would you write that midline?
The midline, you could write y equals 0 for the midline if you were required to do that. If it hasn't been moved up or down, it's not such a big deal because you could just say x-axis. That'd be the easiest way to tell you where it's at. But it would be y equals 0 if you wanted an equation for the midline. Okay, and then one of the other things we're going to be looking at is where it goes through the x-axis. So our x-intercepts, if you will, are 0 is where it hits the x-axis, and then at pi, and then at 2 pi, and at 3 pi. And if we went backwards, you would have the same thing. You could have negative pi, negative 2 pi, negative 3 pi. So sometimes what they'll do is they'll say multiples of pi.
Okay.
Multiples of pi. Like if you take pi times any number that's an integer, that's where you're going to hit. So if you had to do the left-hand side of this graph, you would know it's going to hit on all of the pi's that don't have fractions. Okay, so that is sine. Sine and cosine are our two wave functions. They're the ones that get used in real life, I think, the most, at least from the applications that I have seen. But we're going to look at some of the others. So let's go over and do cosine. So if I go in, we can just take out the sine. Actually, you can just type cosine over the sine. It's like magic. And then the x. And if we just hit graph, we can see that cosine's a little bit different. So remember that this graph goes up to 2 pi on the edge here. So on the y-axis, it's actually up here at 1. So if we're just looking at this right-hand side of the graph, it's up here at 1. When I get to pi over 2, it's hitting the x-axis at pi. It's down at negative 1. At 3 pi over 2, it's back to 0. And at 2 pi, it's back where it started. So it looks like this. So you still have a period of 2 pi. It's starting over at 2 pi. And then you could draw the next part of the wave in there if you wanted to continue that. So you would still have period of 2 pi, because that's how long it takes for it to start its pattern over. The midline would still be the x-axis, which you could say is y equals 0. And your amplitude is still 1. So it would look almost identical to this, except for where the points are at. It's like it's been slid over a little bit, and it's not hitting the x-axis at the same places. So our x-intercepts are looking like they're going to be fractions. Pi over 2, 3 pi over 2, 5 pi over 2, and it would keep going. And you could go back in the negative direction. This graph is actually symmetric. If I took it over here, this would be negative pi over 2. And so these would all repeat exactly the same thing on the left side. So I'd have negative pi over 2, negative 3 pi over 2, negative 5 pi over 2. And they sometimes would call this odd multiples of pi over 2. So I don't know if you want to write that down, but that's a way to think of it. They just think of it as pi over 2, and then we're taking it times 1, 3, 5. And these two graphs are related. It's just like this one has been slid over a little bit from this one. It's like this graph is this one slid over pi over 2, which is 90 degrees. There's a little bit of difference. Okay. Now, the crazy ones are the ones you guys have not seen, and that's what we're going to do next. So let's go in and do tangent.
Oh, no, no, no.
Okay,
no.
so tangent x is a little weird looking.
I'm freaking out.
So this one is not a wave function. It's a little wavy, but it's a little different looking. So if we're looking at this, this is a chopped up graph. So if I'm just looking at this part where the y-axis is, it's going through 0, 0. And then it kind of, this first notch right here is pi over 2, where there's nothing and it's not connected. If you have a really old calculator, sometimes it'll try to draw a line and connect those, but it's not supposed to. At pi over 2, there is an asymptote, which is a line that basically breaks up pieces of a graph, and they usually draw it as a dashed line. So so this is a pretend line that would be right there, and it's going up on this side and down on this side. And we could go into some specific points, but generally speaking, we just need to know the shape that it goes through 0, 0, and that's what it looks like. I used to know a teacher that said she thought it looked like some sort of weird modern chair. I really didn't see a chair, but you know, if that's what it looks like. And then, so where the next one goes through the x-axis is over here at pi. So So over here at pi, there's another one that hits, and then at 3 pi over 2, we get another asymptote. So this one is not going to have a period of 2 pi. It's not a wave function, which is a little different. So it's going to go like this, it's going to go down like that, and then it'll repeat over here at 2 pi. It's going to be right here. And we're just going to do a general shape, because we're not going to use these as much as the others, but you should recognize what they look like. So if I was going to look at how often these repeat, you could use this first one. So it's going, so basically your other asymptote would be over here, and we could add in negative pi over 2. So basically from negative half of pi to positive half of pi, it's completing a full, whatever you want to call this, we could call it a wave. And so it's like if you take half and half and put it together, you get a whole pi. Half of a pi and half of a pi, you get a whole pi. Now I'm hungry. All right, so we could say on this one that the period is pi. It is a little hard to see because they've chopped it up into halves on everything, but it's pi. It's repeating twice as often as the others are, and they have weird places where you have asymptotes. So some of the facts that we're going to look at on this one, your x-intercepts are going to be 0 and pi, 2 pi, etc. You could have your negatives also. You could put plus or minus pi, plus or minus 2 pi. That's a nice way to put the positives and negatives in there. And then your y-intercept for this one is also 0. I meant to do y-intercepts on the others, but it'll be okay. We'll go back and do it later. And then another thing that they will often ask you is, where are the asymptotes? So on this one, asymptotes, actually I think it only has one S. I'm trying to fix. Yep. So asymptotes are these little lines that break up the graph, and the graph never actually touches the lines, they just get really close. So the asymptotes for this are plus or minus pi over 2, plus or minus 3 pi over 2, plus or minus, you could keep going, 5 pi over 2. So it's odd multiples of pi over 2. So yeah, on an asymptote, which we've looked at just barely in the past, just a little bit, they get infinitely close to those dashed lines. And if you went up high enough, they would look like they were those lines. They never actually touch it or cross it. These pieces of the graph are actually separate pieces. So interesting, it does repeat, but they're separate. And the reason for these, do you guys remember when we were doing the trig functions of general angles, there were some angles that we did get undefined because you'd get 0 in a denominator and we tried to set up the fractions. This is what happens when we try to turn it into a function. You just have parts of the graph that you can't put points on because they're undefined. Okay, so cosecant. Actually, let's skip around. Let's go down and do cotangent, which is the reciprocal of tangent, just because it'll look similar to tangent. So if we go into our calculators and we're trying to do cotangent, so I'm doing this one down here at the bottom. That's the reciprocal of tangent. So we have to know it's the same thing as 1 over tangent theta. So we can't just type in something. We don't have a cotangent button. The -1 is for something else. So we're going to do 1 divided by tangent x is how we're going to type that into the calculator. And we graph it, you're going to see that it looks an awful lot like tangent, but the breaking points are in different places. So the y-axis on cotangent turns into an asymptote, and then there's another one at pi, and another one at 2 pi. If you remember how we talked about the window on the calculators, make this a little bit darker so it shows up. And then we can just kind of draw this in. So at half of pi, pi over 2, we get a similar graph to what tangent had, but it's been flipped. Left and right, it was flipped. And then this one, it's going to hit at 3 pi over 2, and it goes like this. And so if you wanted to put another one over here, it would kind of, you just have like half of it right there, and you could have half of this right here, and sometimes you'll see that. They don't have enough room to show you the whole thing. So it looks similar to what we did up here with tangent, but they are flipped, and their x-intercepts and the asymptotes are in different places. But this one's really easy to see. I've got an asymptote at 0 and an asymptote at pi. So my period for this one is going to be pi. So I'm just going to write period equals pi. And then your x-intercepts, if I can write, are going to be pi over 2, 3 pi over 2, etc., with the plus and minus. Could be positive, negative on each side. And the asymptotes, I'm just going to do ASYM, asymptote, we'll add a P. Asymptotes are at all of your multiples of pi. So 0, pi, 2 pi, etc. Whole numbers of pi. It does not have a y-intercept. It doesn't go through the y-axis because that's where the asymptote hits. It's like a do not cross line, which I think is funny because when you're driving, a solid line is the ones you can't cross, and the dashed ones are the ones you can. So this is kind of backwards because it's math. All right, so you ready to see another bizarre graph? So we went from tangent to cotangent just because they're similar, they're reciprocals. Let's look at here at cosecant. So to put cosecant into your calculator, you have to know it's the reciprocal of sine, and what you're actually going to type in is 1 divided by sine. So on your y equals, I'm going to have 1 divided by sine this time.
Oh, heck no.
And it's going to look weird. I liked this one. I don't know why. It made me happy. It just looks like all kinds of little parabolas. They're not exactly parabolas, but kind of like it. So there's an asymptote at your y-axis. Let me just cover up the left-hand side here. So there's an asymptote at your y-axis. There's another one at pi.
Wait, what?
But pi goes through the middle of it. Oh, I'm sorry, never mind.
This is pi right here, and this graph looks a little different because it's gone all the way out to 3 pi for some reason. Sorry. So this is where the edge of your graph on your calculator ends. So we'd have another asymptote over here. So this also has a period of pi. It's going to repeat. And this little U shape, it's important to know that it only goes down to +1. And this U shape starts on -1, and they alternate. And this one goes up. And then if you were on the other side, sometimes they'll show you over here, hey, here's part of one, over here going down.
Just a little more.
Yes.
How can you tell what is an asymptote? Is it just like...
So it's basically where you can see that they're not connecting.
Okay.
It's this little space right here where they're not connecting. There's a little do not cross line. It's imaginary, but we talk about it as being sort of that boundary line between one part of the graph and the next.
Okay.
This is like the first time you've really had to look at one closely and think about it. Well, we did a little bit with asymptotes when we did our exponential functions. This is kind of your next time that you're going to see it. So on this one, we could do the period. I'll just write it up here, is pi. You could talk about where the asymptotes are, so I'll put ASYMP. The asymptotes are at like pi, 2 pi, 3 pi, etc. And there's not a whole lot else to talk about. Sometimes they'll talk about maximums and minimums for this part of the graph. 1 is a minimum. Up here, -1 is a maximum. That's something we'll get into a little bit more later, and we'll come back to this and look at it. But that's what cosecant looks like. And if you put cosecant and sine on the same graph, which I should have planned and done this little U shape would sit on top at the top of this mountain. And this little U shape would come off the bottom of this valley. When you put them together, it just makes kind of a cool design. Okay, one more. We are almost done. So secant is the reciprocal of cosine. So we're going to type in 1 over cosine theta. So I just did that
Yeah.
on my calculator. And it looks similar to cosecant, except that this one, if you're looking at it with both the negative and the positive side, you'll see that it's got some symmetry. The y-axis actually divides the picture in half. So it goes through the y-axis at 1, and the asymptote is right here. So if you're thinking this is 2 pi, so I'm going to hook my finger here. So here's your division point. So this point right here will be pi over 2, pi, 3 pi over 2, 2 pi. So our asymptotes would be at pi over 2 and 3 pi over 2 this time. So put in those little do not cross asymptote lines. But they're still the same width as all the others that we did. So we could still say that the period was pi. So I'm going to go ahead and make like this little half of this thing. And this one starts at -1 down here and goes that way. And this one over here, I would have another asymptote at 5 pi over 2. I'm not sure why some of these I have it going all the way to 3 pi, but we'll just go with it. Maybe just so we could see more of the picture. I don't remember, because this is just an old one that I've used. And then you could have like half of a thing over here. Okay.